Okay, so the symmetry is odd because f of negative x equals negative x, and because f of x equals x. And that does not equal f of negative x equals negative x.
The line is increasing in both directions, so it's not bounded.
There is no, what is that? Asymptotes, because the line is not curved and will always stay straight.
There's no discontinuity, so the line is continuous.
If you are looking from left to right, you can see that the line is always increasing. Therefore, the line is increasing from negative infinity to infinity.
There are no maxes or mins because the line is always increasing.
The x values are always increasing, which makes the domain negative infinity to infinity, and the same thing occurs with the y values, and that makes the range negative infinity to infinity as well.
As x approaches infinity, the limit is infinity, and as x approaches negative infinity, the limit is negative infinity.
Parent function number 2, quadratic functions.
For the quadratic function, begin by graphing y equals x squared on your graphing calculator. You will be left with a parabola. To get the points, you can look in the table.
For the domain, it is all x values, so they continue till negative infinity and infinity.
For the range, the y values go from 0 to infinity. There is a bracket in front of the 0, then a comma, then infinity, then a parentheses.
For the symmetry, the f of x is equal to f of negative x, so the symmetry is even.
In boundedness, y equals x squared is bounded below.
For the asymptotes, there are no asymptotes because it is continuous.
For discontinuities, y equals x squared is continuous.
Y equals x squared first decreases from negative infinity to 0, and then it increases from 0 to infinity.
For extrema, there is an absolute min of 0 at x equals 0.
The end behavior is the limit of f of x when x approaches infinity is infinity. The limit of f of x when x approaches negative infinity is infinity.
This is parent function number 3. The equation for it is y equals x cubed. The domain is negative infinity to infinity. The range is the same. Symmetry is odd. It is not bounded. There are no asymptotes. There's no discontinuities. It is increasing from negative infinity to infinity, and there is no extrema.
This is parent function number 4. F of x equals 1 over x. The symmetry is odd and it's not bounded.
For the asymptotes, the horizontal asymptote is at y equals 0, and the vertical asymptote is at x equals 0. And for discontinuities, it discontinues infinitely at x equals 0, and it's decreasing from negative infinity to 0, and 0 to infinity.
The domain is negative infinity to 0 and 0 to infinity, and the same it is for the range, negative infinity to 0 and 0 to infinity.
And for the end behavior, when
the limit is f of x equals 0 when x goes to negative infinity, and the limit of f of x also equals 0 from x to infinity.
Hi, I'm going to show you about the square root function, the fifth parent function. The parent function is f of x equals the square root of x. There is no symmetry. It is bounded below. There are no asymptotes. The square root function is continuous. It increases from 0 to infinity. It has an absolute minimum of 0 at x equals 0. X is greater than or equal to 0, and y is greater than or equal to 0 for the domain and range. As x approaches infinity, f of x equals infinity. As x approaches negative infinity, f of x does not exist. As x approaches 0 from the positive side, f of x equals 0.
All right, this is function number 6, which is an exponential function, which is b to the power of x, where b greater than 1 represents growth and 0 is greater than b less than 1 represents decay. And the symmetry is none, because as you can see on the graph that there's no symmetry. The domain is from negative infinity to positive infinity, and the range is from 0 to infinity, and its boundedness is bounded below because there are no y values that continue to negative infinity, and the asymptotes are horizontal asymptotes at y equals 0.
There are no discontinuities, so the graph is continuous. And as you can see, when b is greater than 1, the graph increases from negative infinity to infinity. And when b is less than 1 but greater than 0, the graph decreases from negative infinity to infinity. There are no extremas, and the end behavior is when b is greater than 1, the limit of x to infinity is infinity, and the limit of x to negative infinity is 0. When b is less than 1 but greater than 0, the limit of x to infinity is 0, and the limit of x to negative infinity is negative infinity.
The seventh parent function is the logarithmic function f of x equals log base v of x, which also works for natural logs.
The domain of the function is x such that x is greater than 0.
The range of the function is y such that y equals any real number.
This function has no symmetry.
The function has no boundedness either.
Hot dog, Stephen!
The function has one vertical asymptote at x equals 0 and no horizontal asymptote.
The function is continuous and contains no discontinuities.
The function is increasing from 0 to infinity.
The function does not have any extrema.
The function has an end behavior of infinity when x approaches infinity, and an end behavior of negative infinity when x approaches 0, coming from the right side of the number line.
The limit of x approaching negative infinity does not exist.
Parent function number 8 is the absolute value function.
The equation is y equals the absolute value of x.
The symmetry is even.
There are no asymptotes because it is continuous.
It is bounded below.
Increases at bracket 0 to infinity parentheses.
And it decreases from negative infinity to 0.
The domain is parentheses, negative infinity, infinity, parentheses.
The range is from 0 to infinity.
The absolute minimum, or the extrema is the absolute minimum of 0 at x equals 0.
The end behavior is infinity as x approaches infinity, and infinity as x approaches negative infinity.
For the parent function number 9, the greatest integer function's equation is f of x equals integer x.
For the graph of this function, there is a jump discontinuity at every integer so that every fraction rounds down. An example is any number between 3 and 4 will become 3 on the graph.
The domain of the function is negative infinity to infinity, and the range is y such that y is an element of the integers.
There is no symmetry, no boundedness, and there aren't any asymptotes. But there is a jump discontinuity.
The graph is increasing from negative infinity to infinity, and there is no extrema.
The end behavior is at the limit as x approaches infinity, f of x equals infinity, and the limit of x as x approaches negative infinity is f of x equals negative infinity.
Parent function number 10 is the logistic function. The equation is f of x equals 1 over 1 plus e raised to the x, negative x.
The domain is negative infinity to infinity.
The range is 0 to 1.
There is no symmetry.
This function is bounded above and below.
The horizontal asymptotes are y equals 0 and y equals 1, and there are no vertical asymptotes.
The function is continuous.
It is increasing for all x's.
There is no local extrema.
The end behavior is the limitation of x as x approaches infinity, and x as x, or, okay, I said that wrong. The limitation for x as x approaches infinity is 1, and the limitation of x as x approaches negative infinity equals 0. And also notice how it crosses the y-axis at 1/2.
Parent function number 11, sine function. This function goes through the point 0, 0. The domain of this function is negative infinity to infinity, and the range is negative 1 to positive 1. The symmetry is odd because if you flip it over the x and then the y axis, they line up on top of one another. It is bound above and below because of the range.
This function does not have any asymptotes, and it is continuous. The extrema is local maximum of positive 1 and local minimum of negative 1 because it is an isolated function. There is no x in behavior because it is an isolated function.
This is parent function number 12, the cosine function.
The equation of the function is f of x equals the cosine of x. The function crosses the y-axis at 0, 1. The domain is all real numbers. The range is negative 1 to 1 in brackets. It is continuous, and it is alternately increasing and decreasing in periodic waves. It is symmetric with respect to the y-axis, even symmetry, and it is bounded to both axes.
The absolute maximum is 1 and the absolute minimum is negative 1. This function is oscillated, so it goes up and down repeatedly. There is no horizontal or vertical asymptotes, and for the end behavior, the limitation of cosine x as x goes towards negative infinity does not exist, and the limitation of cosine x as x goes towards infinity does not exist.
Attention staff and students, we have several announcements today. First off, all girls